Hi, welcome to PHP and MySQL video. We are doing example 3, part 3. This is a list of suggestions how you should use this video. The notes for this video can be found here at this URL, which is loaded here. Okay, and the code for the example is you can check under the TST links. Okay. So this is what we try to achieve, but we have been coding it halfway, and this is what we have so far. So we managed to capture the value that user input on the first file on the second file. Okay, and now we need to do the calculation of that calculation. Before we even do the calculation, we need to know how that works, right? So we need to figure out how to calculate a depth. Okay, let's see how to calculate a simple depth. Okay, so let's say we borrow I think I can just write it over here. All right. Let me close this. Okay, let's say we borrow $1,000 from the bank. Okay, and that is year 0. Okay, we borrow $1,000 in the bank. Let's call it investment. Okay. Of course, it's not investment. That's that, but we like to call everything pretty, right? So let's call that investment. Okay, and we have an interest rate of say 20% a year. That is equal to 0.2, right? Which is 20% is equal to 20 divided by 100 equal to 0.2. So the interest of course, interest rate can change. And then the interest you have to pay is equal to 1,000 times 0.2, which is equal to 200. The interest is $200. So at the end of the year 1, your investment is going to be this one plus this one is 1,000 plus 200 equal to 1200. Okay, 1,200. And then now your interest is going to be 1200 at the end times 0.2 equal to 240. And then at the end of year 2, sorry, this is year 1, interest at the end of year 1. Yes, then you generate this interest in year 1. And then year 2, your investment is going to be 1200, which is here, plus 240 equal to 1440, right? Yep. And then the interest generated in year 2 is 1440 times 0.2 equal to 288. And then year 3 investment is 1440 plus 288. I hope my math is correct. If it's wrong, the program is going to tell me it's wrong. 1, 8, 2, 7. Okay, 1728. Yep, so on and so forth. Okay, so you keep doing. So that's called a compound interest, right? The beauty of compound interest is it will grow exponentially. If you that's how compound interest works and how the particles fill the universe, right? 1728 times 0.2, so on and so forth. You can keep going until 30 years, okay? But with a program, things will get much faster. So this is the calculation. So we have to do the calculation here, okay, in the on top here. All right, let's do that. So we want to calculate the future value here before we do formatting. Okay, so the future value is going to be what we have here, but we want to hold it in the beginning as the investment, which is captured in this variable. And then we need to write a for loop. A simple syntax of a for loop. We always write the syntax first. 1. Years. Years is captured here. So no matter what the user input, the for loop is going to loop that way. Increment by 1. Or you can write it this way. Okay, they are the same, pretty much. And then we are going to say, okay, Control S to save. So we have 30 years. Okay, so this part, yeah, we're going to have 30 years here. And the future value is equal to the investment plus the interest rate calculation. Okay, interest rate is equal to whatever interest rate is. So the future value is equal to and I have already saved the future value, the investment into the future value. So future value, you just have to make itself bigger because it's compound interest. So future value equal to future value plus future value times interest rate. But you have to divide the interest rate because interest rate is a number. You have to it's a percentage. You have to divide it by 100, and to divide by 100 is same as multiply by 0.01. Okay, and then I can see what the future value looks like. So now when you submit again, so the first year is oh sorry, year 1 is 1 2. I need a gap here. So I need a gap here. Make it look prettier. All right, year 1 is 1200, which is correct. Year 2 is 1440, 1728, and start things to get complicated and get out of hand. At the end of year 30 is $237,000. That's the beauty of compound interest. Okay, you can make something really small into something huge. It's definitely more than 30 times, right? After 30 years, you actually is 237 times what you originally borrowed. Okay, which is fantastic. That's how banks get rich, right? Okay. And that's how people get broke. Okay, so but this formatting is so scary, right? You put it at the back, and then people will be like, "Yeah, your website sucks." Or I don't want to know the details. I just want to know how much money I owe the bank at the end. So I don't need to show all this. I just want to know the value. So I'm going to get rid of the echo by commenting them out. I don't want to delete them because eventually I may need it for debugging purposes. Okay, so I just say, hey, this is the future value I calculated. I'm going to format it and output below. So let's do that. So in the formatting, my future value is going to be saved into a new, and that formatting is very similar to the investment formatting. So I'm just going to copy this. So my future value, I'm going to use it to create a new variable, future value f, which is a totally new variable, is going to be $ plus the future value that is being calculated. So you are going to show the user 237,000, which is the value here with 2 decimal places. And then we're going to copy this label. Say Control C, Control V, total debt amount. No monthly payment is going to be future value f, which is the value here. Control S to save. Submit. So they're going to say, oh, I have a BR, so the formatting is bad. So the future value, no monthly payment, is going to $237,000. Okay, great. So if you borrow $1,000 from a credit card company, the interest rate is 20%. After 30 years, you own the credit card company $337,000. Great. Okay, so we are done with the passing of value and calculate, and then you have to go back to the first page. You can create a link here to go back to the first page just to make it look prettier. That's great. So we are done with this part. In my example, I actually provided another way of calculation in my example here. Not only, so this is on my website. So the example not only calculate the total debt, you also do what if it's not a credit card debt, it's a mortgage. Mortgage would force you to make monthly payment. So if you borrow $1,000 to buy a small tiny house, probably a dog house, you will be forced to pay back money every month. So mortgage interest is much difficult to calculate, but it forces you to pay back. So if you borrow $1,000 after 30 years, you only need to pay $16 a month. You actually only pay $6,000 through the mortgage. Okay, so compared to the $337,000, $6,000 is only 6 times of 1,000. So mortgage loans are much more reasonable compared to credit card loans. Okay, but mortgage calculation is much more difficult to do. So I have a formula here in my example. So this is mortgage loan payment. We won't be able to do it without going into some serious math. I'm not going to teach math here. So if you want to do it, this formula will do the job. But in my example, I'm not going to do it. It just takes too long, okay? It's not my purpose of this class. So let's try to do a mortgage payment, right? So if you buy a house at $300,000 at an 8% interest rate per year and a 30-year loan, and you calculate, if you borrow credit card debt with $300,000, you are finished, right? After 30 years, even at 8% is $3 million. Okay, it's like 10 times. But if you borrow mortgage loan, monthly payment is $2,000 for a $300,000 house at 8%, and total payment at the end is $792,000. It's only like you only pay 4,932 interest rate. It's only 2 times or 2 point something times of the original instead of 10 times for credit card. So to buy a house, don't use credit card. use mortgage loan. Okay, but just for fun to see the difference, it's kind of interesting. But I'm not going to do it here because it just takes too much time. All right. So in the next video, I'm going to do some kind of input validation, okay, to make sure the user input the correct things to the system. All right, so that you don't get the wrong value in your calculation. So that's what we're going to do in the next video. But after this video, you can do most of the exercises, most of the assignments, most of the simple stuff that we do. You don't have to do the error checking in some of the assignments. Okay. Thanks for watching. We'll be right back.